In this video, we're going to begin to look at the examples from Chapter 4, Section 2, about working with the point-slope form of a linear equation. And the point-slope form looks like this. Y minus y1 is equal to m times x minus x1. Now, where does this come from? Well, it's very closely related to the formula for a slope, for the slope of a line. So if we started with m is equal to y2 minus y1 over x2 minus x1, and then we were to multiply both sides by this denominator, x2, x1, x2 minus x1, like so, and then we canceled the denominator on the right side with the x2 minus x1, we would have ended up with something that looks like this. y2 minus y1 is equal to m times x2 minus x1. Now, if we knew the slope, but we only knew one point, then we could write an equation simply by erasing the subscript from x sub 2 and the subscript from x sub 1, and what we would end up with is what I have above, the point-slope form of a linear equation. So when do we use this? This is to be used when you have only one point and the slope, or when you have 2 points but not the y-intercept. Alright, so we're given above the point negative 8 comma 3, and we have a slope of 1/4. So the first thing that I'm going to do is label my point x1, y1. Notice that the x-coordinate is negative here. So now I'm going to simply insert the x1, the y1, and the slope m into the point-slope form of the equation. So I have y minus, it's always y minus, but here I have a we need to put in the y-coordinate here, and the y-coordinate is simply 3. Y minus 3 is equal to m, which we know is 1/4, times x minus negative 8. But we know that minus a negative is the same as plus, so we end up with y minus 3 is equal to 1/4 times x plus 8. And so this would be the point-slope form of a line that passes through negative 8 comma 3 and has a slope of 1/4. Alright, so what we want to learn first of all in this section is how to take a point and a slope and to put them into point-slope form. So I'm going to go on to the next 2 examples below, and we'll see how straightforward this can be. Alright, so in the second equation below, when number 1, I am always going to write my formula first. This helps me to memorize the formula, and it also shows me what it is that I need to plug in. I'm never going to plug in for the y by itself, or by the x by itself, or the x by itself, but I'm going to plug in for the m, for the x1, and for the y1. So let's see how that looks. So I have y minus y1 is negative 1 is equal to m, which is negative 2, times x minus 3. And so I simplify y minus negative 1 to be y plus 1 is equal to negative 2 times parentheses x minus 3, and I'm done. So that's all we want to do in the first step in this section, is to be able to take a point and a slope and put it into this point slope form. Alright, with the second, y minus y1 is equal to m times x minus x1. And we start to plug in. Again, I didn't label in these cases, but you really should begin by labeling x1, y1, and this is your m is already labeled, x1, y1. So we know what to put where. So we get y minus y1 is 0 is equal to negative 2/3 times x minus x sub 1, which is 4. The only thing I would do in this case is note that y minus 0 is really just the same as y. So I'm going to get y equals negative 2/3 x minus 4. And that is going to be it for these three examples. And so I'm going to end this video at this point. What have we done? We've learned to take the point slope form of the equation and given a point, an x1, y1, and a slope, m, to insert them properly into the point slope form of the linear equation. Now, one thing that you may want to pay attention to is the negative signs in front of the x1 or y1. If you notice in the first example above, the y-coordinate was negative 8. But when we put it into the equation, it became, the x-coordinate was negative 8. But when we put it into the equation, it became x plus 8. And the same with the one below, where we have the point 3 comma negative 1, and m is equal to negative 2. When we plugged in the y1, which is negative 1, when I simplified, I ended up with y plus 1. So when you plug in the x1, y1, what you're going to get, the signs will always be opposite from the signs that are in the original point. So x1 was positive 3. When we write the equation below, we get x minus 3. The y-coordinate was negative 1. When we write it into the equation, we're going to get y plus 1. And that's because the formula asks us to subtract. So we're either going to subtract a positive or subtract a negative. Subtract a positive comes out to be minus. Subtract a negative comes out to be positive. And we'll stop this video.